Hello my dear children, let me just do the continuation of last video. Okay, as for your reminders, I was in the concept of electric potential, and we learned in the last video that electric potential at any point can be defined as the amount of work done to bring the what charge, a unit positive test charge, basically a what charge, a test charge, positive charge from infinity, and to keep at a point, but in a what field, electric field. That's why electric potential is the characteristics property of electric field, and that is always defined in terms of what, defined when there is a what field, electric field. And let me tell you, electric field is also called as conservative field. Also called what field? Conservative field. Okay, now electric potential and hence the electric potential difference are those physical quantities which can determine the direction of flow of charge. That means charge can always flow when there is a potential or potential difference, okay, between 2 points. That's why there are some important note that we need to discuss. Number one note is there: electric potential of a conductor determines the direction of flow of charge when the given conductor is connected to another conductor. That means one conductor connected to another conductor means basically this conductor are connected with, say, an example like a battery or cell. You know, when you connect a conductor or wire with a battery or cell, then what happens? This battery or cell provide a what difference? Potential difference, okay, between the two ends. And when there is a potential difference between the two ends of a conductor, then definitely there is a flow of charge takes place from one end to other end. And this concept is also we utilize in the next unit, that is current electricity also. But remember this much: the current, electric potential, and hence the potential difference, okay, determine the direction of flow of what charge from one point to what point, another point. Okay, but which charge flow from one point to another point, or from one potential to another potential, that can be even given by the concept of potential. But let me tell you that positive charge always flow from the higher potential to what potential, lower potential. Yes, we learn in case of potential difference, when there is a potential difference between 2 points in an electric field, the free positive charge, let me tell you the word free positive charge, that always flow from higher potential to lower potential. And this concept I have explained in the previous video also. While the free negative charge, or simply a negative charge we also call, always flow from what potential? Lower potential to what potential? Higher potential. And this concept is also utilized in the next unit, that is current electricity also. Okay, like example, let me just give you the example. Suppose you connect a wire with a battery or cell. Battery always has two terminals. One is called positive terminal, one is called negative terminal. But remember this: the positive terminal battery is always called higher potential, negative terminal battery is called lower potential. Why it is called lower potential negative terminal and higher potential positive terminal? Because when you connect a wire with a battery or cell, what will flow in a wire? The electrons will flow. In electrons, what charge? Negative charge. An electron as a negative charge always flow from lower potential to higher potential, that is from negative terminal to what potential? Negative terminal to positive terminal. That's why the concept of potential and potential difference also explains that the free positive charge or positive charge simply always flow from higher potential to lower potential, and a free negative charge or simply a negative charge like electron always flow from lower potential to what potential? Higher potential. Okay, so this is another important note from electric potential. Now we have a last note that we need to keep in mind, that is at all points where electric field becomes what? Electric field does not exist. That means all point in a region where electric field does not exist, the electric potential is taken zero. That means a point if there is any point where the electric field does not exist, means the potential is always taken zero. Let me take the example of infinity. You know, infinity is such a point where the electric field is zero. You know why electric field is zero? Because the potential is zero. That means infinity is one of the point where the electric field is zero. So when the electric field is zero, the potential is also what? Zero. So these are the three important notes that you have to keep in mind, especially while defining electric potential and the potential difference. Okay. Now the next topic that we discuss in details with electric potential due to point charge, and I'll do in the next video.